Student, this is lecture 4, chapter electricity. Topic is resistors. Any electric component that is made to have a certain resistance is called a resistor. They can be connected in a circuit to resist the current flow. Here are some of the examples of resistors. Resistors may look like any of these ones. There are two types of resistors: fixed resistors and variable resistors. Fixed means having only one value. Those resistors which have only one value are called as fixed resistors. Similar basis, if a resistor can adjust it to change any of the value, that are called as variable resistors. Fixed resistors are represented by this symbol, whereas variable resistors are the same symbol which we use for the resistor with an arrow crossing it or an arrow supplying from the outside. What is the basic difference and what is the importance of a variable resistor? The importance of variable resistors are, these variable resistors are useful in regulating the voltage or dimmer light and electric appliances such as regulators. You must have observed this kind of resistors in your fan, in your ACs, in your fridge, in any of the electric component where we have to change the voltage. So there we use variable resistors. Resistors can be connected in two forms. One is series, one is parallel. Remember from S is straight. When we connect any resistor in a straight line, end to end, we say that it is series resistors. But when we connect resistors in a form of a ladder, one above the other, above the other, above the other, in a form of a ladder, we say that it is a parallel resistor. Single resistor, this is a diagrammatic form of connecting resistors. Single resistor, when two resistors connected end to end, these are series connection. Any extra resistor in series results in dimmer the bulb. Similar basis, when resistors are connected in a form of a ladder, one above the other, then the resistors are said to be connected in parallel. An extra resistor in a parallel results in brighter bulb. Now, very important question. This question comes in this year paper also. How do you connect resistor in series? How do you connect resistor in parallel? Right now, I told you when three resistors are connected end to end. One resistor R1, second resistor R2, third resistor R3. When they connected in end to end, this connection is called as series connection. Resistor, a conductor having some appreciable resistance, is called a resistor. A component of identical size that offer a higher resistance is a poor conductor. An insulator of the same size offer even higher resistance. When three resistors R1, R2, R3 are connected in series, the current remains same. These 2 points you have to remember always. First point is current in series remains same. See from here, emitter is connected here, supply is growing, the current remains same, but the potential is changing. Potential is represented by V1, V2, V3. R1 is having a potential of V1. R2 is having a potential of V2. R3 has a potential of V3. And total V always remains same. V is equals to V1 plus V2 plus V3. Remember these 2 points again. Current remains same. Potential remains equals to V1 is equals to V2 is equals to V3. Current remains same. Here see the arrow representing the current, the values representing the voltage. Now, according to Ohm's law, V is equals to IR. For first voltage, V1 is equals to IR1. See, here I had written V1, but I had written I because I is same. R1 is a first resistance. Similarly, V2 is equals to IR2. V3 is equal to IR3. We know equation V is equal to V1 plus V2 plus V3. We had IR is equals to IR1 plus IR2 plus IR3. I is the same. We take out the I common. I cancel out. So R becomes equals to R is equals to R1 plus R2 plus R3. So when resistances are connected in series, it is equal to the sum of each resistance. It may be 1, it may be 2, it may be 3. Now, this topic, resistor in parallel, we do it tomorrow, but beforehand, you revise resistor in series and you have to write and show me resistors in series and learn the derivative part of resistors connected in series.